What's currently running in your Kubernetes cluster and how secure is it? This is a question that keeps both platform and security teams awake at night. Modern clusters run hundreds, sometimes thousands of workloads, some of which are exposed, others are over-permissioned, and some are doing things they shouldn't. Today, we're thrilled to introduce full workload inventory visibility in ARMO Platform. This allows you to see how every workload behaves, delve into deployment-level context, and understand how workloads are interconnected. Let's explore the risk filter to see external-facing workloads. Let's further examine the behavior of a specific workload. The real-time security graph visualizes how workloads are connected. After all, security isn't just about what a workload is, but what it's connected to. Understanding which services communicate with each other is vital. Unexpected, overly permissive service-to-service communication is a common pathway for lateral movement in attacks. Knowing which workloads are talking to each other can help detect anomalous connections or excessive privilege communications, thereby eliminating potential threats. Workloads exposed through ingress load balancers are high-value targets, whether it's a public load balancer or an ingress. Knowing which workloads are accessible from the internet is crucial for secure design, patching, and hardening efforts. Workloads with access to sensitive resources, like secrets, service tokens, or privileged cluster roles, can escalate to broader breaches if compromised. Mapping these resource attachments helps identify hidden risks and enforce proper isolation and access control. Now, let's switch to the application profile. Understanding how your workloads operate is crucial. For security processes running inside the container, detecting malicious or unexpected processes is vital. It helps in identifying suspicious activities like auto-manning, reversal, or rough binary before they cause harm. Modifications of file accesses often signal security incidents. These incidents usually involve tampering with sensitive files like config files, secrets, or logs. By monitoring file access, you can detect abnormal behaviors such as attempts to read token files or modify binaries inside the container. Workloads making unexpected internal or external API calls could indicate data exploration, privilege escalation, or lateral movement. Tracking these calls provides deep visibility into how an application behaves across lateral movement. Monitoring network traffic is another crucial aspect. Unexpected connections to external or internal services can indicate command and control communication, data leakage, or lateral movement. By monitoring network flows, you can detect abnormal communication patterns and enforce privilege access. System calls are how processes interact with the kernel. Attackers often exploit this layer. Tracking system calls helps detect behaviors like privileged escalation, process injection, or attempts to escape the container. It's critical for layer visibility for runtime protection. Linux capabilities in use should be minimal for the workload. If a workload is using a powerful Linux capability like cap sysadmin or capnet role, it might be overprivileged, making it easier for an attacker to exploit the container or the whole system. Now, let's move to the security posture overview. A single misconfiguration, such as privileged container, can expose an entire cluster. Vulnerabilities. Container images may contain vulnerabilities that attackers can exploit. Understanding which workloads are vulnerable allows you to provide patching based on actual risk, not guesswork. Moving to runtime incidents. Some risks become visible at runtime, like container behavior, unexpectedly accessing sensitive resources, or running suspicious processes. Here we can see a few incidents related to that workload. For instance, crypto mining domain communication detected by process wget. Here we see the exact attack graph. We can see the attack story generated by AI. The full blast radius is visible, and a response can be initiated. It's important to note that not all workloads are equally exposed to the internet. Those running with elevated privileges or lacking isolated control pose a significant threat. Identifying and scoring these risk factors helps teams focus on the most critical workloads. Protection policies like SNetwork policies and seccomp profiles come into play here. These are your in-control security measures. Network policies limit which services can communicate with each other, while seccomp profiles restrict dangerous system calls. ARMO automatically generates both network policies and seccomp profiles. Clicking on the Fix button will automatically generate a network policy based on the workload behavior. ARMO supports different CNIs like Kubernetes, Cilium, and Calico. You can apply a network policy directly from the ARMO platform or download it to your local machine. By combining configuration checks, runtime insights, policy enforcement visibility, the ARMO platform provides a real-world view of the security of each worker, not just in theory but in practice. Thank you for watching.